Hello all and welcome to the Nullcon webinar series. My name is Harshit. I'm part of Nullcon team and your host for the day. The Nullcon conference is a unique platform for security companies and evangelists to showcase their research and technology to the community. Today we have with us Aravind Putrevu, and he is going to present his talk on building a security platform with Elasticsearch. I welcome him on behalf of all of us. Aravind likes to help developers to solve their problems. He has 9 years of experience and worked at Mcafee Antivirus in cloud and data center security. Our today's talk duration is about 30 minutes. Following that, we will have a question answer session, and you all can ask your questions using chat option after the talk. I also request you to please keep your mic on mute during the session. So I invite our speaker to take it forward. Aravind, the stage is yours.
Yeah, thank you, Harshit and Nullcon team for inviting and also managing everything pretty swiftly. So folks, I think I'll just quickly put my screen on, and I would definitely seriously want it to be interactive rather than I say something and leave and you will not learn anything. So something like that. So what we'll do today's session is I have pretty small, not so many slides actually. I have 20-25 slides, and it is not heavy content. We explain and see how the platform is. And then I also promise that whatever I share today is free and open. That means you could go and download and implement in whatever the place. In the interest of time, I might be using something like a cloud, but then you could also do this yourself. So that is a core focus area. Now that being said, there is more to come. I'll explain as we go ahead. So building a security platform with Elasticsearch. So Elasticsearch is a popular developer stack doing different things for different people. So we'll see how you could do something similar, something like that. Myself, Aravind, I work at Elastic as a developer advocate. I run open source communities, meetups, speak at conferences. Fortunately, I've also been, even though Elastic is a search company, even before when we started to see the community pick up security more focused, like the security community looking at Elastic, even before that, I joined Elastic, but I have a bit of, a security background. I used to work in a company called Mcafee Antivirus, where we used to work on data center products, data center antivirus. If some of you have any time worked on EPO, the e-policy orchestrator, or Mcafee virus scan and enterprise. So there is a bunch of code that I have checked in, and it might be running in your laptops as well. So I worked in this sort of a space for quite a while, mostly data and data security part of it. So today's session, the key takeaways that I look at is how do you build a security platform on an open source stack like Elasticsearch? And then I'll also explain what are the myths surrounding this particular stack and what people generally think and go and solve and find on internet and read. And what is something that we already did and probably you could leverage it more often. So in the part one, today we'll see a bit of Elastic Stack 101. Probably some of you might have some knowledge about it, but I just want to reiterate for the benefit of everyone. And then we also have a data ingestion part and the managing the data part. You might think that there is no security or threat hunting or other things. I'll also explain why and why I chose like that and what is the importance of this particular thing. So specifically, when you think about Elasticsearch, it's an open source project, obviously, but it's also a distributed system, NoSQL data store, and also a search engine. So basically, it's like a platform where you need to build, connect, and you can take multiple VMs or machines and build this platform. Unlike your regular SIEM or regular endpoint platforms where you get an appliance and you double click it and it runs. And then and there is a database server that you run probably, and then everything happens automatically. Or some of you might not be really deploying this, and there might be an infrastructure team which might be deploying this. But Elasticsearch is a bit different than what it is. It's a distributed system. It's like your Hadoop. If you have worked on Hadoop is more or less in the similar area. And then you also have NoSQL support. That means like the data that is stored can be queried on a REST endpoint basis and also stored in a JSON document structure. So some of you might be thinking, oh, then probably I don't have access to SQL. I am very good at SQL, and then Elasticsearch doesn't support SQL. No, we have a SQL engine running on top of Elasticsearch, and you can query using the regular your SQL commands on Elasticsearch as well. This is one of the improvements that less talked about, and many people don't know about it. And then whatever I say today, please keep remembering that whatever I speak, it's all free, and I will not definitely, if I speak anything, something related to that you need to pay, I will definitely mention it. So you can think that. Then it's a search engine that you all know. But then over a period of time, what happened is you have Kibana and Logstash, which also plays a vital role in this stack, and then people started calling it as ELK. Logstash is basically for your extract, transform, and load when you have security log sources, or when you have different sort of data need to be pulled. Suppose say you have something like Okta, and then you want to bring in all the sign-in logs, or suppose you have Azure or several platforms, right? SaaS platforms, and you want to have an API and want to poll and bring in the data. You want to need a poller. People write scripts. Then Logstash is something that is suitable to do something like that, where you can query some things like input plugins. There is an input plugin process, and then like you can filter that data, the data that is coming from that API, and then load into Elasticsearch. And then after loading into Elasticsearch, you can also build your own custom UI, which several companies today that you are seeing, including several top companies in the security world, are using Elasticsearch, and they are customers to us even before we started doing this. And they use Elasticsearch at different levels. For example, some of them are technology partners like Symantec, Mcafee. They're technology partners to us. And then you have Kibana. So basically shows that, which avoids that UI and like shows you in a very UI focused manner. But people stopped here, frankly speaking. So everyone thinks ELK stack or ELK stack is the stack that you need to build, and many people don't know the other things that the platform has added over a period of time, just because maybe this is popular and this is very catchy and people didn't realize. So there are two more things that has happened over a period of time, and some of them know it. It's not like not everyone know, but like some of them know, but they also don't know other things in the same area. See, we also have Beats, which is another open source data shipper framework again. And then these are like small agents which go onto your servers and then like pull data from your servers, and then like you can build the data ships to Kafka or any message queue as well. But as well, end of the day, it comes to Elasticsearch in a certain format, and then like it moves on to the Kibana. So we'll also see a data format today, about why it's important for you being a security practitioner, etc. Unfortunately I didn't put a slide, I believe, but then I'll show you that. Then you also have the APM or the code tracing thing. Suppose if you have a specific API, so if you are collecting headers from an API, or want to correlate it with code, want to check some OWASP related rules, and layer over your audit logs or several other log sources or data sources. So code tracing can help. And what the platform offers here is like ability to interact and integrate all of this in a single dashboard or a single pane. So that's what I'll show a bit about it. I'll see if we can accommodate that and show something related to that. So that's the overall view, and this is what is Elastic Stack. And many people stop here, but actually there's a lot more to look at it. And then I'll also explain like what is more solutions are coming in. So based on the stack, we have finalized that like we got to know that there are three probable prominent use cases that people use as well. Like one is search, one is observability, where like operational analytics, infrastructure analytics, more into that area. And then one is which is a very edge case, like you also have the SecOps or the security area actually, which is Elastic Security. So these are the three basic solutions that we are building, and I'll also show there some things there. And when I say solutions, so something that as a developer or as a practitioner you don't need to really worry about, and you can just simply go and click start. So I mean, like, just go and you want some Zeek logs to be added, just click some buttons and things come automatically, which is what is happening with several platforms even today, right? So we are like a developer stack earlier, but we are also getting there, and some of them are already ready, or you might have seen them actually. So Elastic Security is a solution that we are focusing today, and the resolver UI that you see here is the endpoint UI which we are bringing into Kibana. Kibana will have one great security app which does both we are trying to we have already unified, but also like trying to do more, and SIEM plus EDR plus your regular endpoint data, by still reducing the number of alerts, noise, and trying to make sense from the data. Not trying to be a regular SIEM, but also trying to give all the luxury of what you can do with a regular SIEM. So that's what is happening as we speak. So talking about the cluster, so let us get into a bit more deep technical stuff, and then if you have any questions while we speak, I'm monitoring them as well. So if you have any questions, please you can kind of like you could probably like kind of share the things in the chat, and then I'll reply it as and when we get a chance. So please ask questions. So that's what I'm saying. So specifically, like when you're looking at Elasticsearch Cluster, if you are looking to build on any platform, like say some of them might have their own preferred data centers, more into security world, banks and everyone, they have their own security data centers. They are not into public cloud. So when they do this, they want to build their own cluster. So it is pretty simple, but also like as we grow into more and more, you will see why it is difficult, why you need to probably choose an orchestrator, at least something that like a Kubernetes to orchestrate this thing automatically. So again, so there are 3 nodes here. When you build a cluster, the cluster needs to communicate to each other, and then it's as simple as it until it is in the same subnet. Until it is running the same process, it will communicate and form a cluster automatically. And starting up the cluster is pretty easy. You can download the Elasticsearch, open the command terminal, open 2 or 3 command terminals, start each process in different things. It forms a 3-node cluster. It's as simple as it. So as I said, like you have this same command running in each place, and then like the node can be your virtual machine, your container, and can also run any OS. I don't think, because it's a Java system, Elasticsearch is a Java related product, and like you don't have any OS related binding. We run on all sorts of architectures. So we are also doing some things which is very specific to ARM, to run on specifically on ARM related stuff, but it's already available, and the things you can pick up as well if you are focused on that sort of area. And I would like to see more questions if you have any. So that is how the cluster is formed. But then this is not just about the system, right? You want to store the data and analyze the data. So what happens is like unlike your SQL system where you have RDBMS system where you have tables, here you have indexes. So what indexes does is like you have multiple, like index is your logical home, not your physical home. I want to be really specific. So index is your logical home because the data is literally spread across the nodes. Data is not staying in this node, in this node. It's not just for the high availability or resiliency and several other reasons, because it's a distributed system. That means you will also not lose data. So here you have multiple indices. The data is stored across the nodes, and that is where you query it. So where does the physical data get stored? Where does the data really get stored? The data gets stored in shards. Suppose if you take this index, which is marked in yellow color, you would definitely see that the shards are coming here, wherein like you already have that. The data is stored in a physical bucket-like structure internally, which doesn't matter to you actually, because we manage it. Even though you are running on an on-prem thing, we manage it. All that you need to worry about is like, how many shards should I have? What, like, how do you decide the schema of the table? What name the table should be? And if you want to enable some specific settings on table, that's the role of an admin, right? So those are the things that if you are building yourself, and if you are not onto a managed service, Elasticsearch service, you need to do this. But other than that, if you are onto a managed service, you can do this by yourself. I mean, like, people help you to do that as well. So this is how the shards and everything works actually. So a lot many people ask while talking about this, maybe I should have put this in a bit ahead. Why Elastic for security? The reason being it's a developer stack, easily able to build. It gets all the, it's a search engine. You can do a lot of stuff, and then uh, often late when I was working in large companies, security companies as well. One question that people keep asking me is like, I don't want to ditch the data. I somehow want to save this security, the security, the entire event cycle, or the at least the knowledge, and then kind of like you query, being able to query and relate like 2-3 years of data. There is, suppose there are some APTs or some specific use cases that I have seen where like uh, the attacker is quite intelligent. He knows that the data gets purged in the analysis platform after 30 days, and because probably that is the norm, right, a default value. And then the to laterally move, wait for 30 days, like dormant 30 days, and you'll not be able to find it. After 30 days, it'll also go on a exponential format, whether somebody would, so it's like an intelligent APT and advanced APT, and it which changes its form and does all sorts of stuff. And then if you don't have data, and you're not able to correlate patterns, and if you don't have something like a machine learning again, it will be problematic thing. Or even if you want to query that, you will not be able to query that because it's a large set of data. So that's where the search comes into play. You could run queries on a TB of data, like a terabyte of data. Even I've seen people running queries on like a lot of terabytes of data. Of course, the cluster would be a bit bigger than what you have earlier, like say maybe 100 node cluster, or there are clusters in India where there are more than 100 nodes, like 200, 300, 400 nodes that you're all using actually. So search is an interesting thing. And then like it, and the third one comes it like it can run anywhere, be it cloud, be it on custom infrastructure, be it anywhere. You can run it on any place, right? So that is an advantage that you want to. So some of you have raised a hand. If you have any question, like you can just type in the chat and I'll reply. So I'll answer your question, Vaibhav, as well. So just give me a moment. So we'll take a bit of break and then we'll talk about it. So overall, when you look at this entire stuff, this is how it looks like. You have multiple instances, indices, shards, documents. So the diagram misleads you in a bit because the indices are stored in one instance. What is the instance 2 and 3 doing? What is the node 2 and node 3 doing? Something like Vaibhav asked here. So actually, it is not this way in real world. What happens is that the data spreads across these 3 nodes. So that if one node goes off, somebody pulls off a plug in the second node, still your data is safe. Still your events or log sources that you want to query is still safe. It might throw up a flag saying that, oh, I'm in trouble, but it will not say you that, the data is lost, I can't work on it. So there is something called replica shards and a lot of details that I'm not going into today. But basically, like what shards help you to do is like these buckets of data is spread across multiple instances, and then that helps you to save this particular particular situation. And it also helps you to scale the query. Suppose if you are querying a terabyte of data, what we do is like we do parallel computing. So we send the query to all the instances of data that is present into multiple machines, and that does automatically. You don't need to do anything specific. And what it does is like it gets a chunk of work done by each one and collates and try to bring the right, it's just like how working in a team does. Everyone does small work and like everyone patches up and then you get to see the entire release. So something similar that we do, and that's how distributed computing or scaling works here. So I hope that is clear to some of you if you have that question actually. So coming to the next part and more important part, so here like the data ingestion part. Naturally, like when you are talking about ingesting data from multiple platforms, like say obviously the top 3 platforms, like you have a Linux environments, and then you have a Windows environments, and you have something a Mac related environments. So there is a data collection part where you collect the data from all these places using something like beats or your forwarders or anything, right? You collect the data and the data ingestion part, wherein the data is stored into the Elasticsearch and how it is stored, what data format, what is the structure, how can I correlate. There are many questions in this area. We'll look into this actually. And then you also have the data storage part, where how do you manage this data, and then you also have the visualization part. So that's what I mentioned, like event collection, ingestion, storage, and visualization. In a lot of time, what happens here is people generally focus on these like two things, like event collection and visualization. Like how do you, if I do a session, what happens is like, even I do this most of the time, and bring up a cluster, install some beats and start them and show you the data in the Kibana. And we leave the mid part about how the data is structured, because end of the day, when you have specific log sources, which are probably very custom to your application or your team. So what happens there is it is very difficult for you to know how to, then you go to somewhere like Logstash and see how do I tune this data to put in a specific structure. Then you miss out all the things that we have told you in before, right? So that's why I want to specifically focus on the ingestion and storage area, and I'll show you some best practices here and also show you the UI. So like I said, today's session is a bit more focused on event ingestion and event storage. Actually, I'll show you this in UI, but then like I want to share this before you. So when you're talking about event ingestion, people think about Logstash, because that is like your ETL tool, right? Extract, transform, and load. And people write grok patterns to prune through the log lines and then pick up what they want to do, convert it in a specific time period, etc., etc. But we have changed over a period of time. It's been more than a year. I was looking at when this was introduced, and how many people still ask me the same question, that how do I do that in Logstash? It's like so many people actually. So I was really surprised in a way. It is already there, but not many people don't know. So ingest node pipelines, there's a specific node in Elasticsearch which is called ingest node, and you don't need to configure anything unless you are building this cluster yourself. Maybe let me think that if you are building this on your own, you need to set a parameter in the elasticsearch.yaml file, the config file, say that node.ingest is equal to true. By default, all nodes, all our things are enabled, but you want to specifically give a node an ingestion format, then you can enable that. There is more documentation around it. I'll also share you that at a later point of time. But I want to specifically tell the role of doing Logstash based thing is getting reduced. Logstash will still be used as a generic ETL, but there is no need for you to run in another server and try to scale up that and try to do all of this, because we specifically want to make it easy for you actually. So what this node pipelines does is, let me show you then, let us know it. So the next slides are all more, they also have theory, they also have some specific stuff. So what I have is like, I have created a deployment here in the structure here. You could also go and create it. I'll give you a trial so that like you can go and play around with it. It's free. You don't need to put a credit card or something. So you have these sort of deployment patterns. So for more around security or security use cases, even though you're ingesting endpoint data, hot-worm architecture is the architecture. So what is this? Is like, this is like a template, architecture template for you to go and start a basic cluster. You could also take inspiration from it and like deploy it on your own, but you need to connect and do all of this by yourself. But then you can also edit and change this if you want to change here. I'm not doing that, but just if you click that and like you just need to like kind of create this, and it shows you a like kind of your username, password, etc., etc. So I have, in the interest of time, what I've done is like this. I have created it. It takes 3 minutes or 4 minutes. Rather than waiting here, I just want to like kind of go ahead and show you this particular stuff. Okay, it shows me the username, password, and open Kibana, and then I can look into that. The same thing is available here. So when you come to Kibana, I hope you're able to see my screen clearly. But if someone has some, the thing is very small, so let me know. I'll also see chat and answer every question at some point. So here, if you see, it is properly divided. Earlier, it was not. So if you think here, it is not in the previous releases. We are also working on that to make it better for you. So now it is a bit changed, and then you have different sections for each sort of thing, and security gets its own section, and you also see more things like endpoint related data, EDR related stuff, sensors and stuff that's coming up here very soon. Then you see that whenever you click on this particular thing, you will see let me click close. We are already in the home. Okay, so when you see this particular the particular UI, you see some add events kind of a section. You go and see there are multiple integrations. Some integrations are spread across multiple places, like how do you generate logs and get data from security thing. Say if I want to look at something like Zeek logs, and then I have an instance, and I want to pull it through the Polar, and I have a Debian in place, a Debian instance, and then I just want to enable this module, and then the data flows in, and I also construct a dashboard automatically for you to go and look at this data. So this is all normal. So what generally people are doing in the community, in the security field, is they are not using this. They are not using this module, and they are trying to reinvent using the same thing, but they don't know how to structure this data, how to do all of this data. And then they end up building this by themselves, wasting a lot of time, while we do all of this pretty easily. I'll also show something here. What fields we capture, what are the things that we store in the data. Maybe not all are exposed onto the dashboard, like a metrics or aggregations, but then you could also do it using our, like there's a lens, there is a new visualizer, which I'll touch upon in a minute. But then you could also structure this data in a format. Now, in the interest of the data ingestion itself, like I said, I'm going a bit fast, but I'll tell you because in the interest of time. But then I'll tell you, when you go to this home, you can go and see what are the agents that are there. Click on the specific integration, and then download it and run it on whatsoever setup you have, whatsoever box you have, and then you collect the data. This is the standard way to collect the data, and this is the way that you can leverage more. So what we have done is we have launched integrations page itself. So it is elastic.co/integrations. Let me go and look at it. So you have this integrations where you have security specifically, and we try to update, even though if the Kibana thing, that page is not updated or not so relevant or useful for you, we have more metrics here. Like say there are sign-in logs, event hub logs, checkpoint related thing. We also have, I think we recently introduced a module for CrowdStrike. Yeah, oh, here it's there. So you have CrowdStrike, other modules are also coming, like for specifically ingesting VPC logs. So more into that area as well. So you could do all of that. So Okta related logs, and this is log sources, metric sources, and as and when you go do more, you will also get more features around it. And when you click one of these, and probably you would go and like look at, you can look at like details of how you can do that. So this is one improvement that we have done very recently. But then if you want to come back and see things here, you could see the modules that are there in the specific thing, and you could also integrate that and look into that. But that's a standard way to look at the entire thing, and that's a standard way to download and beat and run it and set up these things. So that what happens, when I open this, say suppose I have a file, if I audit beat data that is being run in here, and then I have and then it is kind of like running it for a while. So I don't know why the file integrity is stopped, but again, so it shows all the metrics automatically, and then it shows you the details. This dashboard is automatically built. So that is how it works. So let me also show you some more things here. And then like I said, we're talking about the data management. So the first and foremost stuff that when you are building a cluster, think about security, like security of the cluster that you are building for the security platform. I know it's convoluted, but it's very important. Basic auth is free, RBAC is free. So there is nothing that you need to worry about it. Like, so you just go to users, create as many as users that you want. And you could also assign roles and create specific role for your user agent. Many people, what they do is, they kind of, they figure out that, okay, the security isn't there. And then like you kind of like try to do it some other way, put a proxy before the cluster, and unfortunately do a lot of things which we think is not appropriate. And probably like you could leverage this particular stuff. And that is what you need to really think about. And then like I spoke about security, so keep that in mind. But then you also have the ingest node pipelines that we just spoke about. So there are multiple pipelines specifically. What this pipeline does is, suppose like say if you have an auth log, right? See, there are processors, like we built a processor to process the log that is coming in, and then we automatically make it available. There are different processes that we are doing right now. And on failure, what happens? On success, what will happen? How the data will be looking at it. So let me show you edit and see. You can also test this pipeline, right? You can also look into that sort of stuff as well. See the timestamp. Somebody was asking the timestamp. So there is a timestamp repo where you can give this particular formats and say what timestamp that you specifically look at. So let me see if I could find that is probably more useful for you people. Let me figure out, or else I'll show you at the later point of time. But there are logstat specific the date formats that are mentioned in one specific place where you can find a list of them, and then like you could go and leverage that. Okay, where is that? Okay, here. Yes. Great. So specifically, this is for pipeline for passing the authorization or security logs, and then you could do a lot of things like adding more and more stuff. We recommend using this thing. If you have any questions, you can raise on the Discuss forum, and we want to answer this. We are also coming up with more improvements in the same UI so that you will be able to pass any sort of log. And we also coming up with a standard log parsing stuff. So you don't need to run Logstash at all. Logstash is our own product, but we are only telling you don't need to specifically work and worry about it. Just simply use some of these to make it more easy for you to run all of this go across scripts. So I don't know how many of you know it, but I'll show you. There is a grok parser here in the dev tools. So you should also definitely kind of like go and kind of like look at this particular stuff. Like, where is that? There's a grok debugger here, and where you can paste the sample data and grok pattern and simulate how the data would look like. It's a pretty bit old. A lot of people don't know it actually. So that is one other thing that to look at. So yeah, ingest node pipelines is very important. There are a bunch of pipelines here that we already have. Okay, it's a old cluster, but you could also go and look at all of this actually. So this is about the data ingestion. How do you ingest? How do you tune that? We will also talk more about the ECS in the next part of the discussion. Like the next time when we do that, we will definitely look into that. So what is ECS? That we'll do a specific session on that itself. So that what it does actually. So whenever you are putting data from multiple sources, say you might have 20 different security products, and you might have a DLP, you might have IPS, IDS, you might have separate SIEM solution, separate endpoint. Everyone don't buy from the same company, but you might want to try to build a one security event platform or one thing that you want to correlate, right? At least correlation is more important in security use cases. So what happens is we did a common schema. It's called Elastic Common Schema. What we did here is we have a specific partners like Cisco, Palo Alto. They also authorize this, like they also agree to this particular thing and contribute or ship the data in a structured format so that you don't need to worry about it. So when you install a FileBit and start shipping data from a Cisco router or a router log or a specific log, SNMP log or whatever it is, we structure it in a specific format automatically so that you can correlate when it comes to the Elasticsearch, and then you want to see it in Kibana. So you can overlay data from multiple data sources from different systems, like from a server, from an IDS, from an IPS solution, and then you can do all of this correlated single point of time. All the beats, all the things that Elastic provides, we make sure that the data is correlatable and is an ECS format. That is why whenever you see the dashboarding thing that we have seen, it shows ECS. So that means like the schema is common schema, and that you could the data is stored in Elasticsearch in that way. We also add some metadata to it. Suppose if you are collecting data from a specific public cloud and we add the region, we add the availability zone, we add more container related stuff, whatever, we add more of that AppSec related stuff as well. So if you are more interested into it. So ECS is an important concept. We'll take a look at more and a bit deep into what thing can be done as actually. So one more thing that I want to do here is like the index management. So when you store all this data, like I said here, if you see, when you store all of this data here and the data gets bigger. So one regular question that everyone asks and nobody generally speaks unless you come and ask on our forums is, you know, how do I kind of like manage this data? Is there a way that I could cut the cake, still keeping the interesting stuff? Like say, I want to find out how many alerts have come from specific VPC or a specific, how many this type of privilege escalation requests that have come or like specific things that have come. I want to keep those events number, but throw away the event to the data to a specific, long storage system, like say S3, like an internal file storage or a server that you can push all the rough data, like a data lake. So what happens there is like index management or index lifecycle policies help. A bit pre-intro to that is roll-up jobs. So what roll-up jobs basically does is you take an index, you take a specific terms or specific values, and based on the date, you kind of like collect the collective intelligence from that data and then store it in another index. So what people does is they have specific I'm not getting the right word to tell, but they have some process in play that I will store 15 days of logs of this particular system. And if there is a SaaS company, or if a company is, it depends on if it's an internal protection team, if the team is working in a SOC or a NOC kind of things, which is publicly exposed, different use cases, like in a public service as well. So what specifically happens here is you can collect all the data and then store it in an index. So that is the job that you create. It's like a cron job, but it does that intelligence for like 20, 30, like 15 days, 30 days, then like 1 quarter, half yearly, annually, and people all do all of that. So what this does is like collect the data and keep the intelligence. Then the index management, what it does is like cut the cake out of this. Like when the roll-up job process is done, we pull out the data and then like we put it in a different place. So I have an example here where I can show. So if you see here, I have a Sarikata logs where I'm putting it from specific 90 days from that index creation, delete the data. And then probably there's also a roll-up job, and there might not be roll-up job because we just want to throw away all of the data. But then people do that as well. And then like you do all of this stuff. So I'll also cover what is hot phase, warm phase. It is nothing but when you want to, so Elasticsearch allows you to put different sort of hardware pieces, hardware boxes like SSDs, inexpensive spinning disk, like a commodity hardware. And then when you push data into it, and then for the first 1 week or 2 weeks, you want 1 petabyte, you want to run that query and get it in like 30 seconds, maybe like say, you want to get it in 1 minute or so on 1 petabyte data. When you put a query, you don't need to go for a coffee and come back. It simply should come. That's what your expectation. And that also the time frame is like last 7 days. And for next level, like after 7 days, you go to 15 days, 30 days, and then 45 days or 60 days, you go sequentially more and more. So the hot phase is a phase where you want that particular amount of days of data in a specific place, and the querying will be faster. And that is where the hot phase come in. And then you also have the warm phase, wherein the data is still hot, but it is not really as faster queryable in terms of like, the other way. Say like suppose after a quarter, I'm talking about very real, very more aggressive platforms where the data is more. People do it annually as well. So people move the data from hot to warm annually. But for an aggressive timeline, people move it every 30 days or 15 days as well. So this hot, warm, cold, frozen phases are the phases wherein you move data from one point to another point, and then you just need to configure these policies. You just need to set these jobs when you reach that stage, and you don't need to really worry about all of this, and there is enough documentation about it to do all of this. So you might think that this is more work, and this is more complex than your regular platforms, but what you're trading here is like your ability to query on large amounts of data, your ability to do more analysis, find more stuff, interesting stuff, and fixing things in much faster manner rather than getting frustrated. So that's what you will be able to do that here. So yeah, this is about index lifecycle policies, hot form phase, and then many things here. And then what index management does is like applies that onto an index, and then like it shows you how the storage is and more stuff. And then like you also have a monitoring part to monitor this cluster itself, which we are not talking today, but that's also very interesting as well to look at. So yeah, so I think I did cover about the ingest pipelines here, and then I did cover about index lifecycle policies. I spoke about this particular thing, like how do you put the storage and management, like you have a hot data, you have a warm data, cold data, and then you have a frozen data. So this is time tiered data, like hot, what is hot for you is your organization's own, like your manager's own this thing. If you think that everything is hot, perhaps you are missing something. You will definitely have something that you don't want all the time, and you could use something like a roll-up job to qualify it into different places. And then there are different stages actually. So in the index itself, there are different states that you can manage, like open index, searchable, high heap memory; frozen index, searchable but no heap memory, a bit slower searches; closed index, wherein like not searchable but no heap as well, but the index is in the place. Personally, I don't think that you need to worry about all of this unless you are dealing with a large scale platform, or even again, I don't recommend you to go to closed index, etc. So you just need to simply like kind of do this tiering. When you choose this platform, we create automatically the policies. When you choose a hot form architecture, the ILM, everything is automatically done. So it automatically flows. When the data crosses 30 days, it cuts off data from one place and puts in another place. That's where the usage of Elasticsearch service or something can help you do more easily. One more thing that I want to cover here, we are trying to bring in.
Hey, Aravind, sorry to interrupt you. We have last 5 minutes remaining. So
Yes. So I just want to tell you here is like there we are doing more improvements in the snapshots area as well. That is one another thing. So like I want to open up and take enough questions. I do have some more bits to tell, but again, like I said, it is a lot of big thing. So what you have here is in the second part that we do, we will collect data through beats and all of these flows, etc. We'll do a SIEM overview. We'll also see a bit of Elastic endpoint. So how does it look like? I'll quickly show you here. So this is a new Kibana. We have done a new feature. So upon this, whatever I showed you today, which is GA, which is live and which is production approved, we did one more thing, or we are trying to continuously improve this ingestion flow and ease of access for you people. So we have introduced another free and open stuff called Ingest Manager, which is an experimental feature at this point of time, just got released yesterday, and where you have a bunch of integrations, and you just need to choose the integration, say like you will be able to manage the agents. So we have introduced something called Elastic Agent, and then like what you could do is like download the agent, put that in your place, and then kind of like it collects some specific modules, and then like kind of if I click on continue, if the agent is there, it starts reporting here. And what we specifically focus here is to like kind of help you to collect metrics much easily, help you to manage that stuff more interesting, like say advanced options. Okay, yeah, the streams. So you have log streams. You have this is more advanced and more easier for you to look at. So this is about system stream, right? If you are talking about, if I add another data source, like say something like AWS or different data sources, then see there are integrations. So these integrations are comparatively 9 or 10 at this point because it just launched yesterday or day before. We will bring everything to the desks, and then what you could do is like you'd also do custom stuff pretty easily. So yeah, so all this is coming in. So there are it's just matter of time, and you can leverage more interestingly. So we'll cover a bit of not exactly the ingest manager, but a bit of like more from the data point of view, easiest point of view, collecting the flows, etc. I'll also get my colleague, a security specialist, from the APAC, and then he kinds of like can help you like kind of do all of this much easily, actually. So that's great, and that brings us to the end of the session. Community.elastic.co is a platform where we run several of these meetups, so you can potentially like join us there if you want to take a spin for the use cases that I showed today. So this is the URL. You can start up a trial, and I can help you if you want to like test drive some of these features here in this place. Thank you. Any questions? So there are some questions.
Thank you, Aravind, for this informative session. Hello, all. You can ask your questions using chat option. You already got some of the questions in chat, so just check if you have answered them already or if there is any new question arrived.
Yeah, I'll share you the timestamp patterns. There is a specific page that I'm looking at. I forgot. I'll definitely share that. Can we call ELK as a SOAR solution? Yes, there are already some companies which have built SOAR solutions on Elastic. We are doing now late, but it's already there. And then like I didn't show you here, we already have some integration, some stuff that is going on here. We have detections, we have rules. We have done a lot of stuff, over a period of time. And we also this interesting threat hunting or like the analyst use case wherein you can analyze the data and put that and do that. So it's coming, it's there. And also, yeah, obviously machine learning along with machine learning, all of this comes with along with machine learning. Like if you see here, a bunch of like the jobs that you enable automatically, it does that and gives you that stuff more easily. So one more question, like okay, is that okay? That Arif question is the last question. Anyone, if you have any questions, you can ask me now. So no questions. Maybe you either didn't understood or like you understood completely. So yeah, there are more cases. We have integrated ServiceNow and multiple things here recently. That's the thing. So the end game or the end sensor notifications come here, so that like if you want to debug or look into it, and then you will be able to do that as well. So one more question here from Poonam, say like how replica works. Replica automatically comes into the play. Say let me show you one specific thing. So when you create an index, say this is the index command. So when you create an index, you have these methods. Like okay, let me put this. So you have these headers just to follow through. Health status index primary replica here, right? 1 1 showing 1 1. So say suppose you take where is that? Suppose you take a specific index like audit beat, right? I just started this one now. So audit beat, I'll copy paste, and I'll see the settings of this index. So you just need to set this setting, and all of this, if you are custom creating an index, which I don't recommend you to do it, by the way. So please don't do this. Please use the tools and leverage it. Please use something that we build and we manage that. So you don't need to worry about all of this. So here, if you see the entire details of that field is given here, the number of shards, replicas, the fields that are there for this index, number of replicas. So when you create this replica, no two replicas will stay stay in the same node. So that means like you create an index which is like this.
I mean, last 2 minutes. Yeah,
sure. So we share an index, and then when you create an index, this gets created. When you have shards, the shards get spread across every place. So it's not like it doesn't. So no replica shard will stay in the same place. So there are primary shards, replica shards. Your primary shards will also spread. Your replica shards also will spread. Your things go for a toss. You will still have the data to be working. It will not have any problem. Okay.
Sure.
So I think there are enough documentation actually. And one more final question, I think, like we have is, can we get any contact to that? Okay, I'm there on Twitter. You can throw me any questions there, and I can guide you where you can reach from there. Thank you.
So thank you, Aravind. Thank you once again for this informative session, and thank you all for your participation for today's webinar session. We request you to please let us know your feedback about the session. We have shared the link in chat option. Also, don't forget to check on Nullcon's upcoming online training 2020. You can again find the details in chat option. And we'll have our next webinar session on securing ICS SCADA system by Dr. Farooq Kazi on 4th July 2020 at the same time 12 p.m. IST. So see you all there, and thank you for your participation. Thank you all.